All right, our last topic of the week is joins. So, why would we bother with joining data? The reality is that often information is going to be scattered across data sets, and it's very rare for there to be a single data set that can get us all of our answers. And so when we're joining, there has to be an identifier or a key in common to merge. So there has to be a reason for us to go through with joining data. And I like to ask myself the following questions when it comes to joining. The questions are: what columns or variables uniquely identify each observation in the data set? What columns do they have in common? And what columns have the same names but mean different things? So I really like the textbook examples of the flights and airports and all of those things in that flight universe, so we'll be using that for this example. And so when you're joining data set, when you're merging the information from multiple into one, you have to make sure that you understand the keys. And so keys are, the primary key is the variable that uniquely identifies each observation. And this is going to be in the main data set that you're working with. So I think of that as like the first data set that you're dealing with, the one that has the most information that you want to pull in. And the key is just whatever identifies that, okay, this is this unique row and that every row is unique from each other. A compound key is when more than one variable is needed. So in the baby names data, for example, we have the name, but the name can be duplicated across time. So the key would have to be the name and the year. The name itself, and the year that it occurred in. The foreign key is the variable that corresponds to the primary key of your other data, the data that you're pulling in. And so for me, the best example is always thinking about when there are country abbreviations and you want to pull in the full name. The data set that has the full name and the abbreviations is going to be your foreign data set, and those abbreviations will be the foreign key. And I have that in example later. You're going to want to check if they uniquely identify each observation, so these keys, using count. You don't want keys where n is greater than 1. And you also need to check if there are missing values. So using is NA, you don't want any missing values. And then a surrogate key would be when you add in something like a row number if it's too complicated to locate the data. So just having a row, so flight 2001, as opposed to having to look for UA 430, which is the carrier in the flight that departed at 9 a.m. 2013-103. That's really complicated when instead we can just have a row key. So essentially, like, to boil it down, I think of this as a game of matching. What matches what and what uniquely identifies each row. There's different types of joins. So the first is mutating joins. They're far more common. And this is when you're going to add new variables to one data frame from matching observations in another. So I think of mutating, you're adding to the original data frame. We have inner joins and then outer joins, which are left, right, and full joins. And then we have filtering joins. These are when observations from one data frame is based on whether or not they match an observation in the other table. So you're reducing the original data frame. So mutating, adding, filtering, reducing. And this is going to be semi-join or anti-join. So joins. One thing that I've encountered is that inner join versus full join versus semi-join feels really, really similar. So here's a way to distinguish between the three. Inner is going to include all rows that appear in both the primary data and the secondary data. Unmatched in either are not included, and columns from both are included. So it becomes wider and longer, but it becomes a lot wider because the columns from everything is included. Full is going to include everything, all rows and all columns from both data. It's often not super appropriate because you get tons of NA values. And then semi is going to return all rows from your primary data that have a match in the secondary data. So it doesn't include anything from the secondary data. So inner, columns from both, unmatched rows in either not included, full everything. Semi doesn't include anything from the secondary. So it feels like they do similar things, but they are different in what they pull in. And then practical use. Like when you're thinking about what do I want to do with this join, I ask myself, what information does each data frame contain? Do I need to match this information to all flights or just a subset of them? Like, do I need to match to everything in my data, or am I really just interested in a subset? Do I need to keep all of the columns, or do I really just want one column from that secondary data? Those are questions to ask. And we can see here in this nice visualization that in flights, time, hour, and origin are the same keys as in weather. And tail num is the same key as in planes, and carrier and airlines and so forth. So you play a matching game of, okay, what says the same thing in each data set, and do they have the same names? Sometimes they can have different names. And then we're going to conclude with an example, hotel bookings example.r. We'll pull things from across this lecture and what you need for your challenge this week. So let's go to RStudio. Let's look at joins. Again, I really like the book's detailing with the flights, so we're going to use that. We're going to go ahead and practice our joins here. So we're going to pull in data from airlines, and this records carrier code and the full name of every airline. Carrier is the primary key. We're going to look at airports, which records data about each airport. FAA is the primary key. Planes, data about each plane. Tail num is the primary key. Weather records data about the weather at origin airports. Time, hour, and origin are the compound primary key. And then flights records data about flights leaving New York City. Time, hour, flight, and carrier is the compound primary. So it's not always easy. Sometimes you have to pull in multiple columns for the primary key. So let's double check if those keys are good. Not for every example, just a few. First, again, we're going to look at count. So count counts the observations in each group. It lets you quickly count the unique values of one or more variables. Great. And what we're going to do is we're going to open up airlines, this first one where we think the carrier is the primary key. We're going to count carrier, and then we're going to filter to see if there's anything where n is greater than 1. And we see, great, there's no value. We look at this table, 0 observations. There's no value in which carrier does not have n greater than 1, so it functions as a key. And then let's check about NA values. We're going to do in is NA. You can look here. NA is a logical constant of length 1, which contains a missing value indicator. Is NA indicates which elements are missing. So airlines, filtering anything that is NA, and great. Here again, there's 0 rows in which there are NA values, so this is just a great double check to make sure that your key is the right one. So let's practice. Let's practice inner joins. Let's say our question is that we want to see which airlines are faster than others on average. We want to choose, what airline are we going to take our flight with? What is the fastest one? Let's start with just a representative flight. We're just going to look at JFK to LAX, and we're going to compute mean airtime for each. So here, as always, I'm creating a new data frame just so that you can compare. I'm opening up flights. I'm piping then. We're using string detect. So string detect, origin is JFK, and destination is LAX. And let's look at this. So JFK, LAX, flights. Flights has, 336,000 observations. JFK LAX flights has only 11,000, so that's quite smaller. Let's create a summary. So new data frame summary. We're opening up JFK LAX flights, then grouping by carrier, summarizing the mean airtime is equivalent to the mean airtime, ungrouping, and then arranging. So let's look here. And we can see that the mean airtime, the lowest one is from the AA carrier. But AA, UA, B6, whatever, I don't know what that means. So let's pull in the airline name by joining. So we're going to use left join to match the carrier column in our airlines dataset to the rows of flight summary. So I want the matching whatever AA is, I want the full name. Same thing for UA and so forth. What we're going to do is we're going to use our left join, and again, I'm being really redundant. I'm naming every in-between data frame just for you to go back and look at it. But we have flight summary left join. We're specifying flight summary is our left data frame, airlines, and then by is carrier. I like specifying what I'm joining by. You don't have to, it can run without it. I just think it's good practice, so it's really clear what we're joining by. So let's look, great. Now, AA is American Airlines, UA is United, and so forth. So now we know what each airline name is. This is a great example of when joining is valuable, when you have an abbreviation for one thing, but you want to know the full name, because you or your readers might not have the insider knowledge to know that UA is United. Right join is going to work the same as left join, but what it does is it keeps every row in the second data rather than the first. Personally, I never use right join. I always use left join, and I always just have my primary data first, and that's just how it works for me. But right join does the same thing. So here we go. American Airlines, JetBlue, and so forth. So let's expand our analysis to also include flights from LGA to Atlanta. So we're doing the same thing, same process. Filter, string detect, our origin and destination for both JFK or LGA to Atlanta. We're creating a column called trip. So we're combining origin and destination into one using the dash as a separator, grouping by trip and carrier, summarizing, and so forth. So let's see. Now we have trip JFK to LAX, mean air, with AA, B6DL, and etc., and then LGA to Atlanta. And we're going to do the same thing. I want to know the actual names because I don't know. I haven't flown enough to just know what UA means off-site. So same thing, left join, we have our flight summary, and then we pull in airlines. And then you see here, I didn't specify by, it worked the exact same. Again, that's a personal preference for what you choose to do. We can also use inner join, which only keeps matching observations in X and Y. So let's see here. So flight summary to inner join. Same thing, right? We've got our trip, our carrier, our airtime, and the name. But full join isn't going to be appropriate. Full join isn't appropriate because it keeps everything of X and Y, and not all carriers are in our flight summary data, so it just doesn't make sense. So let's see here. Lots of NA values, and we don't need them. So full join is one that I would use only rarely. It's not super common. It can be useful, but just be really intentional with what exactly is it that I want to pull in. So let's say I don't know what LAX is, and I want full airline and airport names. So I want full airline and full airport names, and so I need to pull in the airports data set. So this is going to combine pivoting and joining. I talk about the steps up here, and then I'll show you down here what the solution is. So first, what we want to do, let's open these. So we've got, here, let's say, let me just pull in data airports. Great. So now it's in here we have the name, and this is what I want. I want to pull in this name value from the airports because I might not immediately know what LAX is. I mean, I know what LAX is, but there's other smaller ones that I might not recognize. And so I want to join my summary with that airline, with that airport data. We're going to join with the airlines. We're going to separate our trips into origin and destination. Pivot longer to spread the values across rows. So we're going to put these in a column called FAA, right? Because FAA, we've got our carrier, our name. FAA here is what we need. We're going to use pivot longer, put into a column called FAA, which matches the column in airports that we're referencing. Using left join to match airports to our data frame. Selecting the columns we need, and then pivoting wider again. So let's look. We'll get that out of here. We're saying flight summary to final. We're opening up that summary that we had before. So flight summary to, let's see which one. Yes, this one. We've got our mean air, our carrier, and our trip. We're joining by carrier. So we've got carrier here. We want to join in this value. We're renaming airline to name, separating that trip into JFK and LAX as the individual components. We're pivoting longer, joining airports, so we're creating a column called FAA. We're joining airports by that FAA value. We're selecting just the values that we need, pivoting, and then arranging. So let's see here. Great. That's all the steps it took to get airline, origin, and destination as their full names. And so filtering. Mutating joins, like I said, those are much more common, but you can also use filtering joins. Semi-join is essentially an alternative to filter. So let's say we want to analyze in more detail the flights that make up that flight to summary final, this. Let's say we want more information about those flights. What we can do is, again, we're going to separate trip. So separating this so that each has its own column. We could use filter, which here we have to say origin in, flight summary origin, and destination in. It's a little bit more complicated to read, or we could use semi-join. So flights, then semi-join by anything in flight summary 3, and now we have just that, all of that flight's arrange time, scheduled arrange time, etc. information based on what we produced in flight summary 3. Let's double check. Great. We only have LGA, JFK, Atlanta, and LAX in this final data set. And let's say we want to analyze everything but LGA, Atlanta, and JFK. Then we could do anti-join, pulls in everything but. So let's look at an example. This example pulls in information from across this lecture and last lecture, so date, time data, recoding, and joins, and we're going to use the hotel bookings data. So again, we're using tidyverse. I'm going to read in a file called hotel bookings. You can find it at this link, and I've also posted this data set under this week. I can use view to see the whole data set. So we see some dates, we see some columns that could be recoded right in here. We've got hotel types, and we can also just use head to just see a snippet of this. So what I want to do is I see that there's a few separate date columns. There's arrival date, day of month, arrival date month, and arrival date year. So here we have these 3 separate columns. And what I want to do is I want to merge into a single column that is a date time type. So we're mutating. Date arrival is equivalent to these 3 separated by the slash. We're creating that as a date month Y object. And then we're removing the 3 columns that we've combined. So we're selecting anything that does not start with arrival and relocating that date arrival to the front so that we can see what we've done. So here, great, we now just have this date arrival column. We're going to cover visualization in a few weeks, but this is just a sneak peek to get you thinking about it. So let's first check out the floor date function. Floor date, it's just going to take a date time object and round it to the nearest value. So this is really helpful for months, which is what we're going to have our unit as. So for this visualization, I'm creating a new data frame called hotel date month, and let's pretend we didn't have that month column ahead of time. Let's pretend we just had this date time object. That's what this is useful for. We're opening up hotel date. We're saying month is the floor date of date arrival, unit is month, so we're rounding down to months. We're grouping by month and hotel, summarizing the count of hotel types in different months, and then let's see what we get. Great. So we have 701 of 2015, City Hotel, there's 1,398, Resort Hotel, there's 1,378. And if I want to visualize this, what I can do is open up this data frame, use ggplot, this is in the tidyverse library, tell it that I want to plot the month, the end value, and the color being hotel, using a line graph, specifying date breaks, like what we talked about in the date time lecture, scaling my y-axis, creating labels, and then angling those labels so that way they're legible. I do something like this. And this is where the date time type is really, really helpful in using, in graphing time. And so let's talk about recoding. There's a few columns in this that I think could be recoded to make more sense. So for example, meal, BB, and country. I don't immediately know what PRT means. And to recode the meal types, I looked through the metadata of this data set, and I learned that BB is bed and breakfast, FB is full board, HB is half board, and SC is undefined. What we can do is, again, we're creating that rounded month column because I'm going to do another visualization example for you. Hotel, date, meal. We open up hotel date. We're mutating for the month. And then I'm just using a simple recode. So meal equals recode, meal, and then bed and breakfast equals bed and breakfast, and so forth. I'm making these factors because that's going to make it a lot easier to visualize. I'm grouping by month, hotel, and meal, summarizing again, ungrouping, and let's see our final result. So here, bed and breakfast, half board, undefined, etc. And let's visualize. Again, specifying with ggplot the data and the columns that I want to plot, the type of graph. I'm using facet wrap, which just splits graphs into different hotel types. That's the variable I'm using. Scaling the x-axis, and then adjusting the label. And so you can recode. I think recoding is, no, I don't think, I know. Recoding is really important when it comes to visualizations like this, where I want the color type to be exactly what it actually is. Like, I don't want it to be BB, I want it to be descriptive. I want it to be bed and breakfast. And so that's just an example of using both time date and recoding to make a more legible graph or a more legible analysis. And so finally, joins. In this data, our country categories are in the ISO 3155-3-2013 format, which I don't know what that means. That's not immediately helpful to readers. And so what I want to do is merge a data frame that lists the actual country frame, the country names out. Now this format is deprecated, but I was able to find a data set that seemed to match pretty well. I found it on GitHub. It's called Countries, Codes, and Coordinates, and it's also uploaded under week 3. So I read in this data set, and we see, great, we've got country and this alpha 3 code, because that's how it's coded in my hotel data. I want to make a column in my primary data, which is the hotel, that references the alpha 3 code of countries. So first what I'm going to do is I'm just going to reduce this countries data set to be smaller because I only need 2 columns. I just need the country full name and the country code. So I do that. So country code's reduced. Now there's only 2 variables. And I've also renamed it so that I have country full and country as the names. Then I'm going to left join country codes by country and relocate. So hotel date, the reason why this only lists 1 data frame is because I have hotel date already indicated as the left data frame based on the piping. I join country code reduced by country, and then I move it to the front. So here, hotel merged. Now I have the full name, which is what I wanted. PRT versus Portugal. Portugal is a lot more descriptive to me. And then just a quick example of what I can do with that. I can group across the variables, so hotel and country, summarize the counts, ungroup, and then arrange so that we can see in hotel country N what are the most common countries that folks come from. And by far we see that Portugal, for both city hotels and resort hotels, are the most common in this data frame. So that's it. That's an example of joining. We had a little bit of strings and recodes in this data set.